Hey everybody, I'm here with you to start chapter 5 of geometry. This is section 5.1. We're going to start this chapter talking about mid-segments of triangles. And really this whole unit is going to be working through different relationships within triangles. And one of those things is a mid-segment. We're going to start talking about that today. So our objective, our learning target, our goal for today is simply to use properties of mid-segments in order to solve problems. So we got to know what a mid-segment is first. So let's talk about that as we get going here. All right, in your notes, if we start off, it says connecting the midpoints, so midpoints, the middle point of a segment, of two sides of a triangle creates a segment called the mid-segment. So that's why it's called the mid-segment, because it connects two midpoints in a triangle. Now, there's a theorem here that deals with mid-segments, and the theorem says, in Theorem 5.1, the first theorem for this chapter, says there are two special relationships between the mid-segment of the triangle and the third side of a triangle. So here's the two relationships. It says if a segment joins the midpoints of two sides, in other words, it's the mid-segment, then the segment is parallel to the third side. So in this case, what we're saying is segment DE, that is parallel to segment AB. And you can tell from the picture, they look parallel, but they are, it's proven. And it's half as long. So it's either half as long as AB or AB is twice as long as DE. So you can write it as DE is equal to 1/2 of AB. But you could also say that AB is 2 times DE. So those are two relationships that the mid-segment gives us in a triangle, and we're going to work with those today. So a couple things, how to break it down. The mid-segment is blank to the third side. That would be parallel. So that's the first important thing to break down here. Second thing, the length of the mid-segment is half the length whoops, I just spelled that wrong. Half the length of the third side. And when connecting the midpoints, what conclusion can you make? Well, you can make both of those conclusions, and that would be all about the mid-segment. All right, so there's some information about today's key term, the mid-segment, and the theorem about the mid-segment. So if we look at this picture here, you can have up to 3 mid-segments in a triangle. And in this case, the mid-segments of triangle AB would be segment XY, XZ, and YZ. And it says, what two things do you say about XY? Well, we can say XY is parallel to AC, and based on the theorem, we know that XY is half of AC, if you look at the length. So let's take a look at some examples here on the next page. It says, find the length of the indicated segment. So one, we're looking for AC. We're given DE, which by the markings here, since we have AD is congruent to DB, and BE is congruent to EC, so we got these here. We know that DE is the mid-segment, so that it's half the length of AC, meaning AC has to equal 30. Okay. Now in number 2, we're given the opposite. We're looking for the mid-segment. We know the mid-segment is half of that, so SU would have to be half of 10.6. So that's the third side, and half of 10.6 is 5.3. So that's what SU would equal. So there's that's using the second part of our theorem 5.1, that the mid-segment is half of the third side. We're going to continue using that here in numbers 3 and 4. Number 3 says find the value of x. So again, we know that 3x has to be half of 5x plus 7. But you might be saying, well, that's going to give me some fractions, and depending on how I solve it. You could also say that 5x plus 7 equals 2 times 3x, and that might be a little bit easier to do. But I'm going to leave it with the original, and we can go from there. Because remember, there's 2 different ways to solve this original. you could distribute the 1/2 right away, or you could multiply both sides by 2 to get rid of that 1/2. I'm going to do that because that gets rid of the 1/2. And then we're left with 6x equals 5x plus 7. And really, it only takes one step to solve for x, getting the x by itself on one side, because 6x minus 5x is just x, so we're left with x equals 7. Now that's dealing with that one. However, in number 4, we know that AB is a midsegment. We're not given lengths of the midsegments, we're given lengths of the sides. So don't assume that one of them is half of the other. If this is a midsegment, then these DB and BE have to be the same, because B would be the midpoint. So now we're just saying that x minus 7 equals 2x minus 17. So slightly different problem, so slightly different way to solve it. But now that we have it set up, we can solve, get x alone. We have negative 7 equals x minus 17, and then I can add 17 on both sides to get x by itself, which is equal to 10. All right, so let's look at graphing. Let's look at a coordinate system here a little bit. Now, before we really talk about this coordinate system, we need to review a couple of formulas. And you'll understand why in just a second. So I'm going to add a page here to just talk about 3 formulas that we've learned in the past. Or at least 2 formulas. But I want to review the midpoint formula and the distance formula. So remember, midpoint is what we're working with because midsegments create midpoint. Midpoint is a point, so it's an x and a y, but it's halfway between the endpoints of a segment. So what we can take is the 2 x values, x1 plus x2, and divide it by 2. And then you do the same thing with the y's, y1 plus y2, and divided by 2. And that's how you get the y value for the midpoint. So we see a midpoint, xy would be taking the coordinates, and really you're finding the average of the x's and the average of the y's. So we're going to use that in just a sec. The other one is the distance formula. And the distance formula is how you can find the distance between 2 points. And this is essentially the length of a segment. And distance formula, you may recall, has a square root. So it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so if you don't have those memorized, you might want to write those down in your notes. So pause it here and write those down. But we're going to use those to help us solve this example here. So it says triangle ABC has vertices negative 4, 1, 8, negative 1, and negative 2, 9. And DE is the mid segment. So I don't have a graph right here with me. Well, if I know that I have a triangle ABC, I'm just going to kind of draw it out here. I'm looking at segment DE, which is the mid segment, where D is the midpoint of CB. So D is right here, and E is the midpoint of AB. So this is kind of what it looks like, and it would be on a graph though. We have certain coordinates. So like A is negative 4, 1. B is 8, negative 1. And C is negative 2, 9. If you can read that there. So if we want to find anything about that mid segment, we need to know the points of E and D. And if we want to find the length of it, we also need to use the distance formula. So what I'm going to do is find the coordinates of E and D first. And we should probably add a third part in here, but the coordinates of E and D. E would be the midpoint of A and B. So we take negative 4 plus 8. Those are the x values, and divided by 2. And then 1 plus negative 1. Those are the y values, and divided by 2. And 4 plus 8 is 4. Negative 4 plus 8 is 4. And that divided by 2 is 2. Negative 1 plus 1 is 0. So divided by 2 is 0. So my coordinate here is 2, 0. And then for D, I want to, let's say, negative, or 8, negative 1, so it's the midpoint of B and C, so 8 plus negative 2. Divide that by 2. And then for the y's, it's negative 1 plus 9. Divide that by 2. And I would get 6 over 2, which is 3, 8 over 2, which is 4. So there's my two coordinates. 3, 4, and 2, 0. Now the second question, now we can find the distance of ED using that distance formula. We could also find the distance of AC and verify that they are the same. They're like half of, ED is half of AC. Part B just asks us to verify that it's parallel. So how do we find parallel? Well, I'm going to go back and add one more formula here that I didn't add, and that would be the slope formula. So remember that when you're finding parallel versus perpendicular, slopes have to be the same. So y2 minus y1 over x2 minus x1. So we're going to use that right now. So slope, we need to find the slopes of each of them. So the slope of ED, we're going to say ED, and the slope of AC. If they are the same slopes, then they truly are parallel. So y2 minus y1, so 4 minus 0 and 3 minus 2, that reduces to 4 over 1, or 4. AC would be 9 minus 1 and negative 2 minus negative 4. We get 8. This becomes a plus over 2, which is 4 over 1. So same slopes, they are parallel. So that was just verified right there. So that's one application of coordinate geometry with midsegments of a triangle. So we've got 5 examples here based on the shape to the right. I would like you to pause and try these 5, and then I will quickly go over them once you are done. So pause and try right now. All right, so I got R, for number 1, I got RS is 24 because we know that RU and US have to both be 12. So the whole thing is 24. Number 2, what is the value of x? We know that 2x and 11 need to be equal to each other, so you set them equal to each other and divide by 2 to solve it, and you get 5.5. Similar for number 3, to find the value of y, we know that 15.9 is equal to 3y, so you divide both sides by 3 and you get 5.3. Number 4, what is the length of UW? That would be the mid-segment here, so it's got to be half of ST. Half of ST is 11. And similar thing for UV, it's half of RT, which is 15.9. All right, so that's the last one I'm going to leave you with today. And those are all questions dealing with the midsegment, using properties of midsegments to solve problems. And we know 2 properties of midsegments now, and that would be that the midsegment is half of the parallel side, and it's also parallel to the third side of the triangle. So that's section 5.1. Have an awesome rest of your day.